Hi, my name is Alex Fleischman, and welcome to the video overview for the open and closed air tube demonstration. This demonstration will introduce students to simple sound waves in both opened and closed air tubes. Students will differentiate the harmonic frequencies in a tube and their relation as the tube is opened and closed. Let's begin this demo by placing an amplifier at one end of an open tube and play the fundamental frequency value. To calculate the fundamental frequency, use the equation F is equal to V over L, where V is the speed of sound, 340 meters per second, and L is the length of the tube. Now, using information obtained from the previous step, try to play the second harmonic for the open tube. You should hear an increase in wave volume levels. If you haven't found the second harmonic already, all you have to do is multiply the fundamental frequency by 2. Let's now create a data table. Our fundamental frequency is 160 Hz. Now, let's find the first, second, and third harmonic frequency. Well, a couple of my students found that the first harmonic frequency is equal to the fundamental frequency, 160 Hz. The second harmonic frequency is 320 Hz. The third being 480 Hz. So from this data table, how can we relate fundamental frequency to the different harmonic frequencies in an open air tube? Well, we could state that the frequency for harmonic n is equal to n times the fundamental frequency, where n is equal to 1, 2, 3, and on and on. Now close an end of the tube and try to play the second harmonic by doubling the fundamental frequency. Well, that didn't work, so now let's try tripling the fundamental frequency. Well, that worked. We heard an increase. This is the second harmonic of the closed tube, but we had to triple the fundamental frequency. Now let's try to find the third harmonic. Well, this occurred when we multiplied the fundamental by 5. Now let's make the same data table we made with the open tube. Well, my students found that the first harmonic frequency is the fundamental, 160 Hz. Then they found that the second harmonic frequency is 480 Hz, and the third was 800 Hz. So what generalization can we make about closed tubes and the harmonic frequencies? Well, we could state that the harmonic frequency is equal to n times the fundamental, where n is equal to 1, 3, 5, etc. Let's review. Open tube harmonic frequencies resonate as multiples as their fundamental frequencies. Closed tube harmonic frequencies resonate as odd number multiples of the fundamental frequency.